Earlier, we learned that ionic compounds are formed because of the electrostatic interaction between positively charged cations and negatively charged anions. We also learned that multiple cations and anions combine to give you a crystalline structure. However, they combine in such a way or in such a ratio that the overall positive charge is completely neutralized by the overall negative charge. For example, in case of sodium and chloride ion, because sodium is 1 positive and chloride is 1 negative, so the ratio is 1:1. So when the crystal is formed, the total number of sodium ions will be exactly equals to total number of chloride ions. This is crucial information to figure out how to write the formula. If the charges of cations and anions are equal, then they will combine in 1:1 ratio. However, in some other cases, cation charges and anion charges may not match with each other. For example, if cation, in this case lithium, has only one positive, and anion, oxide, which has two negative charges. In order to balance this, for every one oxide anion, we will need two lithiums because each lithium is 1 plus. So 2 lithium will be 2 plus. So overall charges will be neutralized in such a way. So in this case, we will need 2 lithiums for every 1 oxygen, or in other words, the ratio will be 2:1. In case of sodium chloride, the ratio was 1:1. It means for every 1 sodium ion, we needed 1 chloride. However, in case of lithium and oxide, we need 2 lithiums for every 1 oxygen. If cation is 2 positive and anion is 1 negative, so in this case, in order to neutralize the 2 positive, we will need 2 of iodides. Or in other words, the ratio is 1:2. It means for every 1 cation, we need 2 anions to neutralize the charge. Last example or last case you may see is when cation is 3 positive and anion is 2 negative. In this case, only ratio which will work or which will neutralize each other will be 2 cations for every 3 anions. So 2 cations, each cation is 3 plus, so 2 cations will give you 6 plus, and 3 anions, each one is 2 negative, so overall it will also be 6 negative. So the ratio will be 2:3. Let's learn how to write the formula of any ionic compound. I will start by taking an example. So in this particular example, we will learn how to write the formula of an ionic compound formed between calcium metal and oxygen nonmetal. So I will explain this method step by step. So step number 1 is that you identify which element will result in formation of cation and which element will result in formation of anion. We know that cations are positively charged ions and anions are negatively charged ions, and we also learn that metals lose electron and hence they form positively charged ions, or in other words, calcium will give us our positive ion or cation and oxygen will give us our negative anion. Once you identify your cation and anion, next step is that you look at the group number to which your metal and non-metal belongs to. So in our example, the metal is calcium and calcium belongs to group 2A. If your metal belongs to main group or A category or A kind, all you need to do is look at the number of the group, which is 2. That will be the positive charge of your metal. Hence, our calcium metal has 2 positive charge. On the other hand, in case of non-metal, to identify what will be the charge, you need to subtract 8 from the group number. So group number is 6. So 6 minus 8, so that gives you -2. So hence the charge will be -2 of your non-metal. Once you identify the charge of your metal cation and non-metal anion, next is you figure out the ratio by which they neutralize each other. In our example, the total positive charge is 2 plus and total negative charge is 2 minus. So 2 plus and 2 minus, they are equal. If your charges are equal, the ratio which will work is 1:1, or in other words, for every 1 calcium you need 1 oxygen. So the total number of ions are written here as subscripts, and by convention we do not write ones, hence the formula is CaO. Let's practice again by writing the formula of a couple of more ionic compounds. In first example, we are going to write the formula of an ionic compound formed between calcium. Excuse me, that was too dark. So formula formed when calcium combines with nitrogen. So in this case, as we learned earlier, first we need to identify our cation and anion. So our cation is calcium, and we're gonna write the formula of calcium metal, and anion is nitrogen. Next thing, step number 2 is we need to identify which group our metal cation belongs to and our non-metal anion belongs to. If we look at the periodic table, we will find that calcium belongs to 2A and nitrogen belongs to 5A. So 2A means calcium has a charge of 2 plus, and 5A means nitrogen has a charge of 5 minus 8 equals -3, so its charge is 3 minus. Okay, so once we identify the charges, next is to see what ratio they will fit in order to neutralize. And if you remember a couple of slides earlier, we found that if the ratio is 2 positives and 3 negative, then the ratio will be, we're gonna need 3 calciums and 2 nitrogens. So 3 calciums, the total charge will be 2 plus 2 plus 2 plus will be 6 positive, and 2 nitrogens will give us 3 negative, 3 negative, 6 negative. So now the charges are equal. So this is the combination by which they will neutralize each other. Hence the formula will be, so there are 3 calcium ions, so we will write calcium, and as a subscript 3, this 3 represents that we have 3 calcium ions. And nitrogens, there are 2 of them, so we will have N2. So this will be our answer as the formula. Okay. So the answer to problem number 1 is Ca3 and 2. Let's erase this and solve problem number 2. So in problem number 2, the metal is chromium, and pay attention to this Roman numeral, and non-metal is chlorine. Now Roman numeral means, and you can also take a look at position of chromium in periodic table, we will find that chromium is a variable charge metal, and 3 in Roman numeral 3 represents that chromium has 3 positive charge. So our cation is chromium, the formula of chromium is Cr, and anion is chlorine. We do not need to, because this is a variable charge metal, we don't need to look at the periodic table to figure out its charge. The Roman numeral is telling us that the charge on chromium is 3 positive. Now chlorine belongs to group 7A, so in order to find the charge of chlorine, we need to subtract 8 from 7, so 7 minus 8 is -1, so charge on chlorine is 1 minus. Okay, so now the total positive is 3 and total negative is -1. In order to balance it, we need 3 of these, or in other words, we need 3 chlorides for every 1 chromium, because 1 chromium total positive charge will be 3 plus, and 3 chloride total negative charge will be 3 negative. And now these charges are equal, hence the ratio will be 1:3, or the formula will be Cr1. We don't write 1, and Cl3. So the answer is CrCl3. So this will be the answer. Let's learn how to write names of ionic compounds containing monoatomic ions if the formula is already given to you. Before learning the entire name, let's discuss how to write the cations and how to write the names of anions. If your cation or metal ion belongs to main group or a fixed charge metal ion, then we simply the name is simply the same as the metal name followed by ion. So for example, sodium plus is just sodium ion, potassium 1 positive is potassium ion, and so on. If your metal ion belongs to variable charge metal, then we use the Roman numeral in parentheses right after the name of that metal. So for example, iron 2 positive is named as iron Roman numeral 2 ion. The names of anions are generated by replacing the last 3 letters of a nonmetal name with the suffix "ide". For example, bromine becomes bromide, chlorine becomes chloride, fluorine becomes fluoride, and so on. Now that we have learned how to write the names of cations and anions, let's learn how to write names of ionic compounds containing monoatomic ions. In this category, we are going to name those ionic compounds in which the cation is fixed charge metal ion. In this case, the naming is extremely simple. All you need to do is write the name of cation first and then the name of anion. That's it, nothing else. Remember, this is important. Do not specify the charge on the cations, and do not specify how many ions of each type are needed to balance the charge. For example, if the formula is NaF and we want to write its name, so first we need to identify the cations. Cation is always the first element. So in this case, the first element is sodium. So the name of cation is sodium. And then we are done with half the name. So the second half is we need to name the anion. So the name of anion is F. F is fluorine. And we learned previously that fluorine, after it gains the electron, it becomes fluoride. So name of fluorine anion is fluoride. So the total name of this formula is sodium fluoride. Similarly, if another formula is given, MgCl2, first again we will name the cation. So cation name is similar to the metal name, so it's magnesium, hence the cation is magnesium. After that, we need to name the anion. Remember, we are not going to specify how many ions are present. So even though there are 2 chlorides, we don't need to specify that in the name. Hence the cation is chloride, or simply the name of this compound is magnesium chloride. We do not specify how many magnesiums or how many chloride ions are there. Now, writing the names of ionic compounds where the cation is a variable charge metal is slightly more complex. I will explain with the help of an example. For example, if we have to write the name of an ionic compound whose formula is CuCl2. In this case, our metal is copper, and we know copper is a transition metal, and we also know that copper is a variable charge metal ion. So the names of these kind of ionic compounds are written in such a way that first we write the name of cation followed by a parenthesis, and inside the parenthesis we express the charge on that metal in Roman numerals, and then we write the name of anion. So step number one is we have to find the charge on the metal, but that's not that straightforward. We cannot find the charge of transition metals by looking at the group number in the periodic table. So we have to find this charge indirectly. So first thing we need to do is we need to look at the formula of the compound. We know from the formula that there is only one copper and there are two chlorides. We do not know what is the charge on copper metal. However, we do know that the charge on chloride is -1 because chloride is in group 7A. Okay, so because there are two chloride ions, the total charge is 2 times -1 or -2. We also know that in a stable ionic compound, the total positive charge, the total positive must be equals to total negative. So they should cancel each other out. So because we know that total negative is -2, hence the positive must be +2. Therefore, now we can say that copper has +2 charge. So once we find the charge on cation as well as the anion, we can name that cation. So for example, in our case, the cation is copper 2 plus, hence its name is copper Roman numeral 2, and our anion is Cl negative, therefore its name is chloride. Step number 3 is write the name of cation first and then followed by anion. So cation is copper 2 chloride. So this is the final answer. Let's practice one more time. So in this example, we have to find the name of ionic compound whose formula is SnO2. Now Sn is tin, and we know that tin is also a variable charge metal. So let's apply the same 3 steps. So step number 1 was we need to find the charge on the metal. So let's look at the formula. So formula is SnO2. So it means that we have only one metal ion or tin and two oxygen anions. We do not know what's the charge on metal. However, because oxygen belongs to group 6A, therefore charge on oxygen is 2 negative. So this must also be 2 negative. All right, so from now we can figure out the overall charge on the oxygen side. Because we have two oxygens and each oxygen is -2, so the total charge must be -4 or 4 negative. If the total charge is on the negative side is 4 negative, and we know that the negative charge must be balanced by the positive charge, hence the charge on tin must be +4 because charges must be equal. So now we have figured out what is the charge on tin. So tin has charge of +4. So we can write SN4 positive. All right, so if the charge is 4 positive, so the name of this metal cation is tin in parentheses 4, and the name of anion oxygen is, so cation is tin 4, anion is oxide. So the name of this compound will be tin 4 oxide. Let's summarize all the rules we have learned so far. So the main things to remember is that we can figure out the charges of metal ions if they belong to main group by looking at the group number. So the main group cations, their charges are always equal to the group number. Similarly, in case of anions, you can figure out the charge of anion by subtracting 8 from the group number. For example, oxygen belongs to group 6A, so you can subtract 8 from 6, so hence the charge on oxygen is 2 negative. In case of transition metals, we cannot tell the charge of transition metals with the help of periodic table. Transition metals are also known as variable charge metals. There are a couple of exceptions from main group also, which belongs to variable charge. Those exceptions are tin and lead. In case of variable charge metal ions, we use Roman numeral in parentheses to express the charge on that metal ion. The second category of ionic compounds are those which contain polyatomic ions. This table summarizes the most common polyatomic ions. I have created a separate video which is available on Canvas. In that video, I have explained what are polyatomic ions and how to memorize the names and formulas of these polyatomic ions. I highly encourage you to watch that video first before continuing this video. Let's learn how to write the formulas and names of ionic compounds which contain polyatomic ions. Let's first discuss how to write the formula. Now, the basic principle of writing the formula is exactly the same as what we learned previously in case of monatomic ion. In case of compounds containing polyatomic ion, again the principle of balancing the charge is still followed. So in other words, if the charge on cation is 1 and charge of anion is also 1, then they will form an ionic compound in which the ratio will be 1:1. Please remember one thing, that the negative charge on polyatomic ion belongs to the entire unit. So this whole NO2 is a single unit, and this negative charge belongs to the entire NO2. So when they combine in 1:1 ratio, so the formula will be Na1, we don't write 1 in the formula, and NO21, or in other words NaNO2. How to write the name we will learn later, but that's how we write the formula. Let's take an example in which the charge on cation does not match with the charge on anion. Just like before, in case of unequal charges, the ratio of cation and anions are adjusted in such a way that they cancel each other out. So if our cation contains +2 charge and our anion, which is a polyatomic ion, has only one negative charge, in order to balance the charge, we will need 2 of those anions. So one anion is 1 negative, so the second one is also 1 negative, so the overall combined charge is -2. So -2 cancels with +2 of the cation, so hence in our formula we have 1 magnesium, or 1 Mg1, and 2 hydroxides or OHs called hydroxide anion. Now, if we want to represent that there are 2 hydroxides, this is the incorrect way of writing. So this is incorrect. So the correct way is we must put a parenthesis around the polyatomic ion, and then put 2 outside the parenthesis. So this shows that there are 2 OH or 2 hydroxide. So this is the correct way of writing the formula. So now that we have learned how to write the formulas of ionic compounds containing polyatomic ion, let's learn how to write the names if a formula is given. When you want to write the name of an ionic compound containing polyatomic ion, the rules are exactly the same what we learned previously. Again, in this case, we write the name of cation first and then we write the name of anion. If our metal cation is a fixed charge metal, we do not specify the charge on that cation, and we do not specify how many ions of each type are needed to balance the charge. For example, if this is the formula, so our cation is sodium metal and it's a fixed charge metal, hence we write the name of cation first, which is sodium, and then we write the name of polyatomic ion. So this polyatomic ion is called hydrogen carbonate, or it's also called bicarbonate. So both names are accepted, so you can either write sodium hydrogen carbonate or sodium bicarbonate. Both are correct. Simple as that. Let's take another example. In this case, our metal cation is barium. It is in group 2A. It's a fixed charge metal, so hence we do not need to write the charge of that metal. So we write the name of that metal ion, which is barium, and then SO4 is a polyatomic ion. Name of this polyatomic ion is sulfate, and that's the name, barium sulfate. In case we have ionic compound with polyatomic ion which has a variable charge metal, we apply rules which we learned previously. It's exactly the same rules. So I'll explain with the help of an example. For example, if I want to write the name of FeNO3 okay, so first we need to write the name of cation. So our cation is iron. Now iron is variable charge, so we need to write the charge in Roman numeral. So we need to find the charge. How do we find the charge? So we don't know what's the charge on iron, but let's look at anion. So our anion is nitrate. NO3 is nitrate, and we know that nitrate has a -1 charge, right? So this parenthesis, and outside the parenthesis there is number 2. This 2 means that there are 2 nitrates, so 2 times nitrates. There are 2 of them, so 1 nitrate and 2 nitrate. So because there are 2 nitrates, each nitrate is -1 charge, so the overall charge is 2 negative, right? So if the negative part is 2 negative, hence the positive part, which is cation, must also be 2 positive. Hence iron is 2 positive. So we know now iron has 2 plus. So in the parentheses it will be 2. So the name of this compound is iron parenthesis Roman numeral 2 nitrate. Many ionic compounds are found in consumer products. For example, calamine lotion contains zinc oxide and iron 3 oxide. It's an anti-itch lotion. Zinc oxide is also found in sunscreen lotion. Many toothpastes contain sodium fluoride. Antacid tablets contain calcium carbonate, such as Tums. Many polyatomic ions are also found in consumer products. For example, bleach contains hypochlorite ion, sodium nitrate and sodium nitrite are found in many preservatives. Our tooth enamel contains calcium hydroxyapatite, which contains phosphate polyatomic ion and hydroxide polyatomic ion. So at this point, I would like to conclude my lecture. So in this lecture, we learned what are ionic compounds and how to write their formulas and how to write their name. If you have any question, please contact me by email, or you can also join me during the office hour. I highly encourage everyone to join the office hour meetings. I would be able to explain better during the office hour meetings. So bye bye everyone. Have a wonderful rest of the day. Goodbye.